Hello everyone, in this tutorial we will create a complete multi-domain explosion. We add a reference object to set the scale of the explosion. We create the first set of emitters. We add an emitter of type cones to shape the initial smoke trails. We adjust the parameters to get the desired shape. We set the start of the animation at frame 10 and adjust the animation. We add the second Icosphere type emitter that will act as the main explosion and adjust its parameters. We will set the start of the animation at frame 11 to add delay with respect to the first one. We adjust the rest of the animation parameters. We add a smoke type flow to the first emitter and adjust its parameters. In this kind of explosions it is important to keep the smoke densities high to get a good simulation. We add a fire type flow to the second emitter and adjust its parameters. Next we add the domain to check the simulation. In the beginning it's important to keep the resolution low to make adjustments to the shape of the explosion comfortably. We adjust the domain parameters, but we will modify them until we get the desired behavior. As the main explosion is just fire, we will increase the amount of smoke generated when the flame is consumed to the maximum. Press the play button and check the simulation. We will make the necessary adjustments so that the domain contains the whole explosion. We go back to work on the shape and animation of the main emitter of the explosion until we get the desired shape. It is important to work on the shape and animation of this type of emitter to give detail to the explosion. Experiment and take your time until you find the result you are looking for. We add a third Icosphere type emitter that we will use as a residual fire from the explosion and that will inject more smoke into the simulation. We will adjust the shape and animation so that it doesn't change size but its shape remains animated. This way we make the fire more random and interesting. We add the fire type flow like the main emitter. We check the simulation again and make the necessary adjustments. It's normal to go back and adjust the values of the emitters until we find the desired shape. We are going to change the simulation type to all, as we are going to increase the detail and the replay mode becomes too slow. We set the duration and indicate a path to save the cache. We adjust the vorticity to add detail and favor smoke rotation. It is important to maintain high densities when using vorticity so that it does not dissolve the smoke. We create a flipbook to be able to check the smoke in real time. We go back to making adjustments to the emitters to improve the simulation. It is important to check the changes made with a flipbook. We add an emitter for the trails and adjust its parameters until we get the desired shape. We set the start of the animation to 10 so that they start before the main explosion and don't break their shape. We modify the size of the domain so that it also contains the trails. We add a fire-type flow for the trails with a low value of fuel. We check the simulation with all emitters. We add a new emitter group to create a shockwave. It has several advantages to do it this way, as we can avoid undefined fire behavior and spoiling the simulation or having to apply too high a resolution to the domain. We make several tests to adjust its shape, size, and animation. We add a flow of type smoke and adjust its parameters. It is important to set its initial velocity to negative to make it fall on the ground. We add the new domain, making sure to select the correct group. We adjust its size and properties. To prevent the shockwave smoke from rising, we set its buoyancy to 0. Important to raise the position of the shockwave so that it stays inside the domain. If you don't see the smoke when you do the simulation, check that it is in the correct position. We adjust the shockwave parameters until we find the desired shape. We increase the resolution of the domain, check the simulation and make the necessary adjustments. We create a camera for our scene and make a flipbook. It's time to increase the resolution and adjust the parameters to add quality to the simulation. It is important to select the domains properly to avoid adjusting parameters incorrectly. We make the bake of the simulation. The duration of the process will depend on the resolution of the domain and the resources of your computer. We check the simulation. We add HDRI lighting to the scene and adjust the shader parameters. Having two domains each has its own shader, make sure you select the right one before adjusting its parameters. Experiment with the different parameters and attributes of the shader to achieve the desired look. The VDBLab shader allows a lot of freedom. We use a mix of Blackbody and fire to prevent the fire from disappearing abruptly and add detail to the fire. We copy the same colors from Blackbody to fire to keep the same look and adjust the rest of the parameters. We adjust the parameters for the render. We are going to export in EXR multilayer format to make a composition later. We activate the volume direct and emission passes. Before launching the render we will deactivate use nodes in compositing so that the EXR files keep the layers. Next I'll show you the nodes I've used for compositing. Basically there are two nodes to correct the color before merging the two layers and one node to generate the glare. The background is a checker texture with nodes to adjust its size and repetition. I hope you enjoyed the tutorial and found it useful.